Welcome everyone to the study guide review video for the 8th grade Unit 4 test. The best way to use these review videos and the study guide is to do one question on the study guide and then watch me explain that one question of the study guide on this video. Then pause the video, do question 2, and then watch me explain question 2 and go back and forth, right? So you're trying a question, you're checking if it's right. Trying a question, you're checking if it's right. Even if you feel like you look at a question, you're like, I have no idea how to do it, you should try it for at least a minute before watching me explain it, right? That's the way we learn. It's scientifically proven. You learn more. Even if you try something, you get it completely wrong, and then you get explained how to do it, versus if you just get explained how to do it right away, okay? So try question 1 if you haven't yet, and then unpause the video and come back once you've tried it. Okay, so for question 1, we have here is a balanced hanger diagram. A circle weighs 3 grams and a square weighs 2 grams. What's the weight of a triangle? So this is like an equation, right? We have it's balanced. So whatever is on the left is equal to whatever on the right. Okay, there's a couple different ways of solving this. So one way is on the right, I have 1, 2 triangles. And our triangle is our missing shape. We don't know the weight of it. So I can represent that as 2t, right? Because t is what we don't know. That's my variable. And then we have 1, 2, 3, 4 twos. So it's like 2, 4, 6, 8, right? So that totals 8 on the right. And on the left-hand side, I have 3, 6. So 6 from the circles that I know, and then I have 1, 2, 3, 4 triangles. So I have 4t plus 6 equals 2t plus 8. Okay, so one way of solving this is to just kind of write that from the picture, and then solve it by picking something to get rid of and going from there. Okay, you can simplify it a little bit though, kind of from the picture. So if I cross out that triangle, I take it away, subtract it from the right, then I also want to subtract away a triangle from the left, right? And this gets this conceptual idea of solving an equation. You're doing the same thing to both sides of it. Okay, so I can keep doing that here. I'm going to get rid of this triangle and get rid of this triangle, and now it's still balanced. So now we'll have a little bit of a more simple equation. We'll have 8 on the right equals 2t plus 6. Okay, and looking at that, we can see, okay, well, what did we do? We subtracted 2t on both sides. Whoops. There we go. We subtracted this 2t from both sides. So if we subtract 2t, then we'd subtract 2t, and we get 2t plus 6 equals 8. Okay, at that point, we can continue to solve this. 2t plus 6 equals 8. I'm going to subtract 6 from both sides. So like in my picture, I'm going to get rid of 6 by taking away 2 3s, and then I can get rid of 6 here by taking away 3 2s. And I get that 2 triangles is equal to 2, right? That's what I'm left with. 2 triangles is equal to 2. So then we can divide by 2. 1 triangle has to be 1 gram. Okay, so you can write it with the equation. You can kind of use the model to do it however you want, just making sure that both in the equation and in the model, what you're doing to one side, you also do to the other. Question 2, solve the system of equations by graphing. So in here we have to graph these 2 lines. So we'll do one line at a time. We have y equals negative 2/3 times x plus 5. In this, we're first going to identify that plus 5, the positive 5, is my y-intercept. And then we're going to identify that the slope is that negative 2/3. Right, the slope is the number x is being multiplied by, and your y-intercept is what we're adding or subtracting to that at the end. So if I have a y-intercept of 5, it means I go on the y-axis and I put a point at 0, 5. And then for my slope, a slope of negative 2/3 is going to tell me the directions that I'm moving. So my numerator is telling me that I'm going down 2 in this case. It's telling me the like up and down direction that I go. We can think of it as like the height of our slope triangle, or a fall of 2. Okay, and then my denominator 3, that's telling me how much I go right or left. If it's positive, I'm going to go right 3, and that's like the base of my slope triangle. So from this point, 0, 5, I'm going to go down 2, right 3, and I get a new point on the line. Okay, and then I can do that again. I can go down 2, right 3, and I get another point on the line. Okay, and we could just keep going, doing that forever. Okay, on the other side, I have, that's done for that one, and then I have my second equation, y equals 2x minus 3. Here my y-intercept is -3. So I'm going to start my graph down here at -3. And then here my slope is 2. So a slope of 2 we can write equivalently as 2 over 1. Okay, any whole number we can write equivalently by just dividing by 1. So 2 divided by 1, okay, that's equivalent of giving me the directions I go up 2 every time I go right 1. So from this point, I can go up 2, right 1, and then I get a new point that's going to be on the line. Up 2, right 1, and I get a new point on the line. Up 2, right 1, up 2, right 1. And I get this second line. Okay, and we know that the solution to a system of equations is the point where the two lines intersect, or the points where they intersect. So in this case, the solution is the point 3, 3. So when x is 3, then y is 3 for both of these equations. So it makes both the equations true at the same time. Let's take a look at 3. Which system of equations has exactly one solution? Okay, so let's just go through these one by one. In A, we have y equals -x plus 3 and y equals -x plus 9. So looking at these, I'm going to see that these, -x, we have the same slope. The slope is -1, right? When we have -x, it's like a -1x. But they have different y-intercepts. So when you have the same slope and you have different y-intercepts, you're going to get parallel lines. So that one is going to have no solutions. Okay? The other way we could figure that out is we could do it more algebraically. We have that y equals -x plus 3, and we have that y equals -x plus 9. So if we tried to solve this, we would say, okay, well then, if they're both equal to y, they're equal to each other. Now let's try to solve it. I'm going to add x on this side, so then I'm going to add x on this side, and then I'm going to get 3 equals 9. Because that'll go away, and that'll go away. Does 3 equal 9? No, right? You have $3, I have $9. That's not the same. So then we have no solutions for A. Okay? C is basically the exact same. We have no solutions because we have the same slope. We have different y-intercepts. So these are parallel lines. They're never going to intersect. No solutions. And we could do it algebraically. We could set -2x plus 3 equal to -2x plus 9. And we'd solve and we'd get the same thing, actually. We'd get 3 equals 9, which isn't true. Okay? D is also incorrect. If I look at D, and then if I look at y equals x plus 3, and then 3y equals 3x plus 9, this second equation is just 3 times the first equation. So these are equivalent equations. Okay, if they're equivalent equations, that means they're going to have infinite solutions. Because we could multiply by 3 on both sides of the equal sign, and we'd get the exact same thing. So these are the exact same line. All the solutions to one are going to be the same as the solutions to the other. So that's going to have infinite solutions. And so our right answer is B. We can see that because these have different slopes. And anytime we have different slopes, we're going to have one solution. Okay, because when lines have different slopes, it means they intersect once. Okay, because they like cross at some point. The only time lines don't cross is when they have the same slope. They're either the exact same line and they have infinite solutions, or they're parallel lines and they have no solutions. We could also solve that algebraically. You could set the two things equal to each other and you'd be able to get a solution. But I would just be looking when you're doing a question like this on the test for the one that has different slopes. Okay, so if I were doing this, I probably wouldn't write any of that. I would just look at them quickly. And I would say these have the same, I'd have these say these have the same slope, that's no solutions. These have the same slope, that's no solutions. These are the equivalent equations, so that's infinite solutions. Here, different slopes, one solution, B is my answer, right? And this alone is the correct answer with enough explanation. Okay. Cool. All right, now we are just solving some equations. So remember, for these, you should give these a try. Pause the video, come back after you attempted them. That those steps I take might not be the exact same steps you take. That's okay, as long as, you get the same answer, right? You're doing the same thing to different sides of the equation. So I have negative 3x minus 4 equals x plus 3. I'm going to pick something to get rid of. I would probably pick the negative 3x here. I like getting rid of negative x terms. So I'm going to write plus 3x on both sides of the equation underneath my x's. So here, negative 3x plus x, that goes away to 0. I'm just left with negative 4 on the right. And then on the left, you got to be careful. If you have x plus 1x plus 3x, that's 4x. So then we get negative 4x equals 4x plus 3. Okay, now I only have x's on the right, which is good, but I still have numbers, constants on the left. So I'm going to subtract 3 from both sides. And I'm going to get negative 7 equals 4x. Okay, x is being multiplied by 4. So I'm going to undo that by dividing by 4. And I'm going to get x equals negative 1.75 as my answer. Okay. Awesome. For 4.2, you're going to want to start by trying to simplify this by combining like terms a bit. So on the left, I have 2x minus 5x. And then I have this plus 3 and plus 8x. So I've highlighted in yellow my variable terms that are the same on the same side of the equal sign. And then I've highlighted my constant terms. So my variable terms, I have 2x minus 5x. That's negative 3x. And then I have 8 plus 3, which is 11. On the right-hand side, we can do the same thing. I have negative 17 minus 5. Those are going to combine together to be negative 22. And then I'll have plus 8x, because that's my only variable term. Okay, so our first step is that process of combining the like terms together on the same side of the equal sign. Okay, once we've done that, I'm going to go ahead and solve like we know how to. We can pick something to get rid of. Yeah, I always like getting rid of negative x's, so just like last time, I'm going to start out by adding 3x to both sides. When I have negative 3x plus 3x, that goes away. I'm just left with 11 on the right. On the left-hand side, I have 8x plus 3x, that's 11x, and I still have my negative 22. Okay, now I only have an x term on the right, but I still have these normal numbers constants on both sides. So I'm going to get rid of that negative 22 by adding 22 to both sides of the equation. And we get 33 equals 11x. Finally, x is being multiplied by 11. So I'm going to divide both sides by 11. And I go get that x equals 3. Okay, cool. So it's going to be a lot easier if you combine those like terms first. And then for 4.3, we have parentheses. So to get rid of this, to solve, we're going to multiply the number outside of parentheses by the terms inside the parentheses. So we're going to do 3 times x plus 3 times 2, which is 6. And on the right, we're going to do 9 times 6, which is 54, minus 9 times x, which is 9x. Okay? Then we're going to solve this. We have minus 9x. We're going to undo that by adding 9x to both sides. 3x plus 9x is 12x. We bring down the plus 6. And on this side, the 9x goes away, and we're left with 54. And then here, I only have x's on the left now, so I'm going to get rid of that minus 6. And I get 48 equals 12x. Lastly, as usual, x is being multiplied by 12. We're going to undo that by dividing. And we're going to get that x equals 4. Okay. So we have to distribute. Remember, when we distribute, we're multiplying the number outside of parentheses to the 2 terms, or theoretically more, inside the parentheses. So for question 5, we have solved the system. Write your answer as an ordered pair, x comma y. Here we're going to solve using substitution, and we're told that y is equal to negative 2x plus 6. So that means that anytime I see y in my first equation, I can substitute in negative 2x plus 6 for y, because these are equivalent. Right? We're looking for the solution to the system, so we know that whatever x is in the first equation is x in the second, and whatever y is in the first is true in the second, because we're trying to find that point that makes both equations true at the same time. Okay, so to solve this, I'm going to begin by rewriting that first equation, the one that has both x and y in it without one variable by itself. And then I'm going to take this y, and I'm going to substitute in parentheses what I know that y is equal to. Okay, so showing it with the highlighter, I have that y, and I'm going to replace that with negative 2x plus 6 in parentheses. Okay, and now that's helpful, because now my equation only has x's in it. So now I can solve it and get an answer for x. Before, I had 2 different variables, and you can't solve that to just get one answer. But now that I just have one variable, I can go ahead and solve this. So I have 4x, and then I have these parentheses here. So what we want to do is we want to get rid of the parentheses. We do that by multiplying the coefficient, or the number outside of the parentheses, by the 2 terms inside the parentheses. So I have 3 times negative 2x. That's going to be a negative 6x. And then we're going to add 3 times 6, which is 18. Okay, so I get this equation that I'm going to solve. At this point, I recognize that these are like terms, 4x and negative 6x. and they're on the same side of the equal sign, so I can just combine them together. So if I have 4x and then I add a negative 6x, this becomes negative 2x, and then everything else stays the same, plus 18 equals 36. Okay, at this point, this is a more basic equation. I only have an x on the left-hand side. I have constants, my numbers without variables on both sides of the equation. So I can subtract 18 from both sides, and I'll get that negative 2x equals 18. Because 36 minus 18 is 18. And then lastly, x is being multiplied by negative 2. So I can finish solving this by dividing both sides by negative 2. And we get 18 divided by negative 2 equals negative 9. Oh, whoops, I shouldn't box that in. So we get x equals negative 9, and that is the x value of my solution. So that's the x that's going to make both of these equations true. But now I need to figure out what's the y that makes both of them true. So to do that, theoretically I could take either equation, but we're going to start with our second one. My second one says y equals negative 2x plus 6. So this is telling me to figure out what y is, I can take whatever x is, multiply by negative 2, and then add 6. And it's going to tell me that. So here, I just figured out that x is negative 9. So now what I'm going to do is I'm going to substitute in negative 9 for x. And I have y equals negative 2 times negative 9, that's positive 18, plus 6. And then I add those together, and I get 24. So my final answer that we're going to box in is negative 9, comma 24, because that is both the x value and the y value that makes both of the equations true at the same time. Okay, this is the algebraic process of substitution. You take a variable that's solved for, you say, okay, this expression is equivalent to it, and so you substitute that in the other equation for it. Okay, awesome. Now we have question 6. Abba just got a puppy and a kitten. She found out how much they will grow over the next year. The puppy weighs about 25 ounces and will gain about 5 ounces per month. The kitten weighs about 10 ounces and will gain about 10 ounces per month. The following system of equations represents this, where y is the weight of the animal after x months. We have y equals 5x plus 25. So that refers to my puppy, because my puppy weighs about 25 ounces currently and will gain 5 ounces per month. And then the kitten is y equals 10x plus 10, because the kitten both starts at 10 ounces and will gain 10 ounces each month. Oh.
So sorry, I'm just grabbing my headphones.
Okay.
Sorry, I did not mean to interrupt.
You're fine.
I have a really funny video. Just show you at Barley's. I showed some
Oh,
shots. It's so fun.
Okay.
It's like, I'll show it to you later, but it is like, it's gonna make your mind.
Okay, I cannot wait.
I hope you had a good weekend too.
Thank you, I did. Okay, so we're going to solve this system two ways. In 6.1, we're going to solve this by graphing, and then in 6.2, we're going to solve it using algebra. In both cases, we're trying to determine after how many months the puppy and the kitten will weigh the same amount and what that weight will be. So after blank months, they'll both weigh blank number of pounds. All right, so to do this by graphing, we'll do the puppy in red. Okay, the puppy starts out at 25 ounces. So that's going to be right here in between 25 and 30. And then the puppy gains 5 ounces each month. So after 1 month, the puppy's going to weigh 30 ounces. And then after 2 months, it's going to weigh 35 ounces. And then after 3 months, 40, 45, 50, 55, 60, 65, 70, 75. Okay, so we have this line. This is going to be my puppy line. And then we're going to have our kitten line. Okay, our kitten 1 in this case is a little bit easier to graph because it starts at 10 and it goes up by 10 each month. So it's 10 pounds and then 20 pounds and then 30 pounds and then 40 pounds, 50, 60, 70, 80, etc. Okay, so this line represents how much my kitten weighs. And then graphically, right, the solution to the system is when these are the same. So looking at this, we can see after 3 months, they both weigh 40 pounds. Or 40 ounces, sorry. 40 ounces. Okay, so that's the solution to my system. And we can see that graphically because it's where they intersect. Okay, then in 6.2, we're going to solve this using algebra. So solve the system algebraically to determine a second time after how many months will the puppy and kitten weigh the same amount and what will they weigh. So here we use this idea that we're trying to find when they weigh the same. So when does puppy equal kitten, basically, right? Puppy is 5x plus 25. This expression tells us the weight of the puppy. And that should be equal to the expression that shows us the weight of the kitten. They both equal y, so they're equal to each other. Right, we're trying to figure out when they're equal. So we can set that up, and then we just solve the system algebraically. So I can begin, I would probably do this by subtracting 5x from both sides. You get 25 equals 5x plus 10. Then we can subtract 10 from both sides, and you get 15 equals 5x. And then finally, you divide both sides by 5, and you get that x equals 3. So that's telling us this, that after 3 months, they'll both weigh the same weight. But then we want to pick one of these equations, doesn't matter which one, and figure out, okay, actually, how much will they weigh after those 3 months? So now I know that x is 3, right, after my 3 months. So I'm going to substitute in 3 here for x. How much they'll weigh, y is equal to 5 times 3, which is 15, plus 25, and those sum to 40. So just like we got graphically, right, after 3 months, they both weigh 40 ounces. And as will be true on the test, you need to get the same answer for both of these. You did something wrong if you're getting a different answer. Right, but I need to see that you can get it both ways. So this is you showing me get it algebraically or graphically, and this is using algebra. Question 7. Mike is making jam. The recipe calls for 4 strawberries for each apple. Complete the table so each row matches Mike's recipe. So we have 4 strawberries. 4 strawberries for each apple. So for each means for one apple. So in our table, we have 4 strawberries. That's going to be 1 apple. Okay, so then if we see this relationship, we have 3 apples. We're going to have 4 times as many strawberries. So to get from apples to strawberries, we're multiplying by 4. And then to get from strawberries to apples, we would be dividing by 4. So 28 divided by 4 is 7. 7 apples times 4 is going to give us 28 strawberries. So these are giving us combinations of possible strawberry and apple. These are giving us possible combinations of strawberries and apples to make the jam. Now in B, they're going to give us a little more information. We're also told that Mike used 80 pieces of fruit altogether. They wrote 2 equations where x is the number of apples and y is the number of strawberries. How many apples and strawberries did Mike use? Show your work. All right, so now I have my system of equations, and I can solve this algebraically. I see that y is equal to 4x. So this y down there, I can replace that with 4x and then try to solve the equation. So 80 equals x plus y. X we're going to keep as is, and y we're going to replace with 4x. Because again, we're told from our first equation that y has to equal 4x. Okay, and then we just solve this. We get x plus 4x. That's the same thing as 1x plus 4x. It's 5x. Divide by 5. And we'll get that x equals 16. Okay, now that I know that x is 16, I want to find what y is. I know that x is 16, so I can take my first equation, y equals 4x, substitute in 16 for x, and I have y equals 4 times 16, which is 64. So the solution is 16, 64, which, that's like the answer, but it's not really answering the word problem. So we should answer the word problem, right? How many strawberries and apples did Mike use? X is apples, right? So Mike used 16 apples, and Mike used 64 strawberries. And then if we go back to this word problem, that fits these two requirements. There are 4 times 16 times 4 is 64, so there's 4 times as many strawberries as apples. And there are 80 pieces of fruit altogether. 16 plus 64 is 80. Okay. All right, finally, 8. Determine whether each equation has no solution, one solution, or infinitely many solutions. Put a check mark in the correct cell in each row. Okay, so we don't have to solve these all the way. We just need to be able to identify if they have no one or infinitely many solutions. For my first one, 6x equals 6x plus 2. I could try to solve this by subtracting 6x on both sides. But when I do that, I'm going to get that 0 is equal to 2. And that's not true, right? 0 doesn't equal 2. So we have no solutions to that equation. Okay, you have the same variable term, that's 6x. But in one case you're adding 2, in the other case you're not. So those two, you're never going to get the same number for that. So we have no solutions. Okay, in the second one, we have negative 3x plus 8 equals, when we distribute, 2x plus 2. This you are going to be able to solve because we have different variable terms. And you're going to be able to get one solution. So you could solve that. I'll do it really quickly down here. But you don't have to. You just want to recognize that these have different variable terms. So there's going to be one solution, which in this case is 1.2. And then for the last one, we have parentheses. We have 5 times 2x and 5 times 4. You're going to get 10x minus 8 equals 10x minus 20. So you're going to get 10x minus 20 equals 10x minus 20. And that is always going to be true. We have infinitely many solutions because we have the exact same thing on both sides of the equal sign. So those expressions are always equal to each other, no matter what x is. All right, good job, guys. Happy studying.